becomes zero as the cell reaction reaches equilibrium. As the EMF decreases, the flow of electrons to the outside circuit will also decrease. So that is what we have in the EMFs of our galvanic cells. How do we calculate the EMFs of our galvanic cells, and how do we actually go around forming these particular equations? So at the end of the day, we don't have any problem. Let us have maybe another example in which we are going to look at the one which will not be having both two electrons. So let us have maybe the reaction which is taking place between aluminium and chlorine. How will our EMF going to be like, right? So if we are going to take our aluminium, we have, let us have example 2. We have our aluminium 3 plus 3 electrons. We are having a reaction like aluminium solid, and the electrode potential for this one is minus 1,66 volts. Right, let us go for that one. For chlorine, we see to it that our chlorine there is down there, and we have our chlorine gas, right, plus 2 electrons, and we are forming 2 chloride ions, and we are having plus 1,36 volts. This one is straight from our standard reduction reactions. As you can see, both of these ones, they are reduction reactions, right? And we actually want to calculate our reduction. We actually want to calculate our EMF of these particular cells. So we want to see how are we going to actually do the calculation. So first of all, we are supposed to actually find our oxidation reaction and our reduction reaction. So this one is minus and this one is plus, which means to say that this particular reaction can be a reduction reaction. It's not spontaneous on the reduction reaction. So we are going to reverse. So we are going to have our aluminium solid being converted to aluminium 3 plus aqueous, right, plus 3 electrons. And so there is need for us to reverse our electrode potential. It is going to be 1,66 volts. It's now positive. And then that one for chlorine will remain the same, chlorine gas, right, plus 2 electrons, right. We are going to form the chloride ions, which are in aqueous form, and this one is plus 1,36 volts. As you can see, the electrons which are being lost by our oxidation reaction, because this one is our oxidation reaction and this one is our reduction reaction, right? So the electrons which are being lost are the ones which are also being gained by our reduction reaction. So in the case, there is need for us to balance our electrons. So what are we having? We are saying we are having our aluminium 3 plus. Let us see. We're having our aluminium solid, being converted to aluminium 3 plus 3 electrons, and the electric potential already is now positive. And so there is need for us to actually, in our chlorine gas there, we are having our chlorine gas there plus our 2 electrons. And what are we getting? We are adding our chlorine gas right, plus 2 electrons, and we are getting what? Chlorine, sorry. Right? So what are we saying? We are going to get our 2 chloride ions here. Right? So what's happening here is that we need 6 electrons, and here we need 6 electrons, because 3 electrons, it will be very difficult for chlorine to gain the 3 electrons. So there is need for us to multiply our first equation there of reaction by 2, and we multiply this one by 3, so that we are going to have our 2 aluminium solid being converted to aluminium 3 plus 6 electrons. Right? Our 3 chlorine gas is supposed to plus 6 electrons, and then we are going to form the 6 chloride ions like that. Right? So since the electrons are now balanced, we can actually now cancel our electrons. Right? So we can actually cancel our electrons now. So that is what these 6 electrons which we have here are the ones which are being gained here. So we can even cancel them. And what are we going to be left with? We are going to have our 2 aluminium. The overall reaction which we are going to have is 2 aluminium solid plus 3 chlorine gas gives us 2 aluminium 3 plus, right, plus our 6 chloride ions. Right? So remember, there is no need for you to actually multiply on the electrode potentials. Our electrode potentials are going to remain as plus 1,66 volts for aluminium, and that one for chlorine will remain 1,36 volts. But now what we are going to have now is our electrode potential of our cell, which is our EMF itself, is equal to plus 1,66 volts plus 1,36 volts. So the electrode potential for our cell, if we are going to actually add properly, we are actually going to get 6 plus 6 there, we can get 2, then carry 1, we have 4 plus 6, we get 10, carry 1, we are going to get 2.02 volts. So this one itself will be our EMF of our cell, right? So with this, you are actually going to be equipped on how are you going to do the calculation of your EMFs. So with this, stay tuned for lecture number 7, in which we are going to look now on electrolytic cells. I think we have done justice on the galvanic cells, so there is need for us to proceed on to what are electrolytic cells and what's really happening on those particular electrolytic cells. So with this, stay tuned for lecture number 7, electrolytic cells.